Let me tell you the difference between Pico zkVM and the ZK Data Coprocessor. When you look at how Brevis works, there are two parts. One works deep inside the engine room, and the other handles everything that connects to the outside world. Now, the first part is called Pico zkVM. Think of it as the brain that actually performs the proofs. It runs computations inside a secure zero-knowledge environment and produces proofs that confirms every calculation is correct. It is small, fast, and flexible. It is the kind of tools engineers love because it focuses entirely on performance. Brevis designed Pico to be modular so that it can combine simple circuits with more complex logic depending on what you want to prove. In some setups, Pico can even power real-time block proving on Ethereum, finishing a full block proof in seconds using GPU clusters. That shows you how optimized and powerful it is. But then you have the second part. That is the ZK Data Coprocessor. Now, this is where Brevis steps out of the engine room and into the world of developers. While Pico handles the proving, the ZK Data Coprocessor handles the purpose. It connects directly to blockchains, fetches the historical data developers care about, performs the needed computations, and then uses a proof from something like Pico to show that everything is correct. You can think of it like this. Pico zkVM is the engine that makes the car move. The ZK Data Coprocessor is the entire car. It gets you from where you are to where you want to go. The coprocessor is what developers and protocols usually interact with. It makes it possible for smart contracts to read and use real historical data across multiple chains. It lets them prove that the data came from the blockchain itself, not from some central server, and that whatever was calculated on top of it is accurate. There are even two ways that this coprocessor can run. The first is the pure ZK model, where every single task is proven upfront before the results are used. This is the safest and most trustless method. It is perfect when you want complete certainty and don't mind spending a bit more time or computing power. Then there is the cold chain model, which focuses on speed and scalability. Here, validators propose results, and if no one challenges them, those results stand. If someone does challenge and the challenge is correct, the validator gets slashed on Ethereum. This way, developers can handle massive datasets or thousands of users without paying the cost of generating a proof for every single request. So, in simple terms, you can say Pico zkVM is the proving engine. It is what actually runs the maths and produces the proofs. Then the ZK Data Coprocessor is the system that uses that engine to solve real problems for developers. Pico helps with the precision and performance, while the ZK Data Coprocessor helps with access and usability. And together, they make Brevis a powerful bridge between what's happening on-chain and what developers want to build with it. You can learn more about Brevis by following them on Twitter and reading up their documentation. Stay Brevis. So now, do you understand what the difference is between Pico zkVM and the ZK Data Coprocessor?